Imagine watching your cloud architecture blueprint just kind of rewrite itself in real time.
Right.
Like it's actively suggesting structural changes while you are literally still trying to decide where to put the firewall.
Yeah, it's
You
wild.
drag a database icon onto the screen, and before you even configure it, the system drafts a customized security policy and, optimizes the routing tables for you. So, welcome to AWS as it exists today, Saturday, April 11th, 2026.
It is it's a profound departure from the cloud environments of even just a few years ago. I mean, the static infrastructure map that engineers used to just memorize, that has become a living, breathing participant in the engineering process itself.
Right, and navigating that living participant is our mission for today's deep dive.
Yeah.
We are taking a massive stack of sources focused on the current AWS CLF CO2 exam.
It's a new one, yeah.
Yeah, specifically the AI and machine learning domain. And we're pairing it directly with what is actually happening out in the industry right now. Because, if you are diving into these materials, you really need to understand that AI isn't just another service category sitting in a drop-down menu anymore.
No, absolutely not.
It is actively eating the cloud.
Yeah.
It is fundamentally changing the very career of cloud engineering.
We are looking at a landscape that has shifted, honestly, incredibly dramatically over the course of 2025 and 2026. So for you listening, we're not just going to list off what these new tools are.
Right.
We really need to look at the underlying mechanisms behind them and deeply explore why they matter for your future in the industry.
Because whether you are prepping for your AWS Certified Cloud Practitioner exam or, you're just sitting there quietly wondering if an AI assistant is going to take over your daily workflow by next week.
Which is a valid fear.
Totally valid.
Yeah.
But this deep dive is going to separate the immense industry hype from the actual reality. And we're going to start with the big picture.
Yeah, sounds good.
The last couple of years have been just a complete whirlwind. AI went from this highly niche set of tools like something only specialized data scientists and machine learning engineers touched into this massive platform-wide explosion of generative AI services across the entirety of AWS.
Exactly.
So let's unpack this. Is this explosion of generative AI services in 2025 and 2026 basically the equivalent of like the early smartphone app store boom, where suddenly there's a tool for absolutely everything?
What's fascinating here is how accurate that analogy is, provided you scale it up to an enterprise-grade level.
Okay, scale it up how?
Well, during the early smartphone boom, the explosion was about consumer convenience. A flashlight app, a calculator app, a little level for hanging pictures.
Right, the basics.
Yeah, but in the AWS ecosystem over the last 2 years, the explosion is about cognitive automation. We went from having these primitive, highly targeted machine learning services.
Like an API that could recognize a face in an uploaded photo.
Exactly, or maybe translate a document. But we went from that to a pervasive layer of generative intelligence injected into the very fabric of the cloud architecture.
Wow.
You now have services that can generate complex architectural diagrams based purely on text prompts. You have services that can synthesize millions of raw system logs into, like, a single paragraph of plain English insight.
That's incredible.
It really is. So it is an app store boom, yes, but for the fundamental building blocks of global digital infrastructure.
It really feels like almost overnight, the AWS Management Console just lit up with AI capabilities embedded into every single screen. You open a service to check your network traffic, and bam, there's a generative AI prompt waiting to summarize it for you.
Because AWS recognized that generative AI isn't a final destination, and it's definitely not a novelty product anymore.
No.
It is a new operational baseline. The sheer computing power finally caught up with the theoretical science, and as a result, the explosion wasn't just about launching new standalone products. It was about embedding this capability directly into the workflows that engineers rely on every single day.
But, to understand this massive explosion of services, you really have to look at the bedrock literally, that all these services are built upon. Because if AWS is building this massive ecosystem of intelligent services, there has to be an engine powering it all.
And that engine is the core focus of the new certification domains.
Amazon Bedrock. Let's translate this into plain English, because if you are studying for the CLF CO2 exam right now, this concept is completely unavoidable. The sources define Amazon Bedrock specifically as foundation models as a service.
That exact phrase, foundation models as a service, is the precise mechanism driving this entire shift.
Okay, but I am looking at this and thinking, a foundation model is essentially a massive glorified autocomplete.
Right, technically speaking.
Right. It's a highly advanced algorithm that simply predicts the next word in a sequence based on vast amounts of data. So wait, if a foundation model is essentially just a hyper-advanced autocomplete, why is offering it as a service such a massive game changer for AWS and for the people taking this exam?
It matters because of the staggering, almost incomprehensible complexity of what it actually takes to build one of those advanced autocompletes from scratch.
Okay, how complex are we talking?
Unbelievably complex. To train a truly capable foundation model, an organization needs tens of thousands of specialized, highly expensive graphics processing units.
These massive racks of GPUs.
Exactly. And they need months of continuous computing time consuming massive amounts of electricity. Plus, they need petabytes of curated training data and a team of PhD-level data scientists to optimize the algorithms.
So it's not something a small dev team is just doing in a weekend.
Not at all. It is an impossibly high barrier to entry. I mean, to build your own model would require hundreds of millions of dollars before you ever write your first line of useful code.
So it's like a small startup trying to build their own nuclear reactor just to power the office toaster.
That is the exact reality of the industry. So what Bedrock does by offering these massive foundation models as a service is it entirely removes that financial and computational heavy lifting.
Ah, I see.
AWS and its partners companies like Anthropic and Meta, they essentially step in and say, we have already built the reactor.
We did the hard work.
Right. We spent the billions of dollars. We handled the complex data science. Here is a simple, secure API endpoint. Just plug your application into it. It completely democratizes access to state-of-the-art artificial intelligence.
So for someone taking the CLF's CO2 exam, understanding Bedrock is critical because it represents the ultimate expression of AWS's core philosophy.
Precisely.
Which is, of course, abstracting away the complex, undifferentiated heavy lifting so the customer can focus entirely on their specific business logic.
You've got it. You are no longer managing the underlying servers or the graphics cards or the neural network parameters. You are simply consuming the model's intelligence on demand.
That reframes things significantly.
Sure.
But it also leads to the next piece of this, because AWS didn't just stop at giving engineers foundation models to build with.
No, they took it a massive step further.
Right. They built a tool that builds for the engineer, which brings us directly to Amazon Q Developer.
The AI assistant designed specifically for the AWS environment.
Yeah, and the sources dive heavily into Amazon Q, noting that it has officially appeared on the CLF CO2 exam in 2026, and it is fundamentally changing how people interact with the cloud.
It really is a paradigm shift.
I want to put this in perspective for the listener. Is Amazon Q essentially like having a senior cloud architect pair programming with you 24/7, constantly looking over your shoulder and offering solutions?
If we connect this to the bigger picture, that is exactly what it functions as, and it completely shifts the daily reality of a cloud engineer.
How so? Like, what does the before and after look like?
Well, let's look at the traditional workflow just a few years ago. Suppose a junior engineer needed to deploy a highly available web application. They would have to manually write hundreds of lines of CloudFormation templates.
Which is basically just code that provisions your infrastructure.
Right, exactly. And they would constantly be toggling back and forth between their code editor, the AWS documentation, and community forums trying to troubleshoot these obscure syntax errors. It was highly manual, incredibly tedious, and very prone to human error.
Oh yeah, you would spend 3 hours just trying to figure out why a single comma in a JSON file was breaking the entire deployment.
We've all been there. And with Amazon Q Developer, that entire workflow shifts from manual, tedious configuration to guided orchestration.
Guided orchestration, I like that.
Yeah, you are sitting in your development environment, and you simply ask Q, generate a CloudFormation template for a highly available web application, and ensure it follows AWS best security practices.
And it just does it.
In seconds, Q generates the baseline code.
But it goes beyond just generating starter code, doesn't it? I mean, the sources mention it can actively troubleshoot as well.
That is the crucial distinction. Say you have a failing Lambda function, which, for the listener, is a service that lets you run code without provisioning servers.
Right.
Instead of digging through thousands of lines of raw system logs for hours, Q can analyze those logs, identify the specific error, and point out the exact line of code that is broken.
Now,
And it often suggests the fix, too. It is not just an advanced search engine, it is an active, contextual participant in your engineering environment. It understands the specific constraints and resources of your unique AWS account.
that perfectly explains why it is heavily featured on the new practitioner exams. AWS wants every single person entering the cloud ecosystem to know this assistant exists because it just drastically reduces the time it takes to go from a theoretical idea to a secure deployed reality.
Absolutely.
But, if an AI assistant is doing the heavy lifting of a senior architect, it naturally forces a very uncomfortable question about human employment.
Ah, yes. The most common anxiety running through the entire tech industry in 2026.
We have to have this honest debate because every single person listening to this deep dive who is studying for a certification is wondering the exact same thing. Will AI replace cloud engineers?
It's the elephant in the room. But the sources land firmly on a very specific conclusion regarding this.
Which is,
AI replaces tasks, not roles. But it absolutely, definitively raises the floor of what a human engineer is required to know on day one.
okay, here's where it gets really interesting, though, because I want to push back on that task versus roles distinction.
Go ahead.
If the floor is raised and Amazon Q or Bedrock is doing all the basic foundational tasks like writing the basic deployment scripts, configuring the basic network routing, finding the basic syntax bugs, doesn't that mean entry-level cloud engineering jobs are effectively gone?
I see where you're going with this.
Right, like if the AI is doing all the junior level work flawlessly, how does a human ever get a foot in the door in 2026?
It is a highly valid concern. But the reality is that the role of an entry-level engineer has not vanished. The baseline expectations of that role have simply shifted upward.
Explain that a bit more.
Historically, a junior engineer's value was often tied to their ability to memorize syntax or navigate complex menus in the console or execute highly repetitive configuration tasks.
Right, the grunt work.
Exactly. Those are the specific tasks that AI has absorbed. If your entire value proposition as a human is, I can write a basic identity and access management policy from memory, then yes, your specific job function is at risk.
Because Q can generate that policy in 4 seconds.
Exactly. But the role of a cloud engineer, even a junior one, has always fundamentally been about solving business problems using cloud technology. Let's look at a real-world scenario.
Okay.
In 2023, a junior engineer might spend an entire week writing a custom script to monitor server health and log errors. But in 2026, Amazon Q writes that exact script in seconds.
So what does the junior engineer do for the rest of the week?
The junior engineer's job isn't gone. Rather, they are now expected to use the rest of that week to analyze the output of that script and figure out why the server architecture is struggling under load in the first place.
Ah. So the AI writes the policy, but the human still has to know if it's the right policy for the company's specific business goals.
The human must understand the broader architecture. They must understand the nuanced security implications. They must evaluate whether the code Amazon Q just spit out actually aligns with the company's strict compliance requirements.
Because the AI doesn't know any of that.
Right. AI is an incredibly powerful engine, but it completely lacks business context. And more importantly, it lacks accountability.
That's a great point. If the AI deploys a flawed architecture that exposes customer data, you cannot fire the AI.
Exactly. The human is still the orchestrator. You are no longer paid to be a fast typist of cloud configurations. You are paid to be a critical thinker who orchestrates AI capabilities. The floor has been raised because you are expected to operate at a higher level of architectural design much earlier in your career.
And because that floor has been raised so dramatically, the actual day-to-day skills a cloud engineer needs to survive and, thrive in 2026 look radically different than they did even a few years ago.
The traditional two-belt has definitely evolved. The manual tasks have been replaced by new mechanisms of control.
So let's outline these new essential survival skills. The sources highlight 3 specific additions every modern cloud engineer must have right now. Prompt engineering basics, a deep understanding of LLM APIs, and crucially cost management for AI workloads.
Those are the big 3, yes.
So what does this all mean? When it comes to our daily habits, are we all just destined to become prompt engineers and accountants for AI workloads?
Well, while it might sound reductive, those really are the mechanics of modern engineering. Let's break those down, starting with prompt engineering.
Okay, let's hear it.
In an AWS context, this isn't just about speaking politely to a chatbot. Prompt engineering is about knowing exactly how to structure a highly technical query to Amazon Q or a model in Bedrock to yield a secure, efficient, and accurate architectural output.
It's like learning a new programming language almost.
It is an entirely new syntax. Just like you previously had to learn the syntax of Python or JSON, you now have to learn the syntax of context window optimization.
Wait, let's clarify what that means for the listener. What exactly is a context window, and why do we need to optimize it?
Think of a context window as the AI model's short-term memory for a single conversation.
Okay.
It is the amount of text the model can kind of hold in its head at one time. If you feed an AI 50 pages of raw system logs just to ask it to find one single error, you are forcing the model to process a massive context window.
Which I assume is bad.
It's incredibly inefficient. Prompt engineering is the skill of compressing your request, providing only the relevant snippets of logs, and applying specific constraints so the AI doesn't hallucinate an entirely unusable infrastructure.
You have to give the AI precise guardrails.
Exactly.
And understanding how that context window functions leads directly into the second new skill, understanding LLM APIs.
Right, because you aren't just casually chatting with these models, you are building them into enterprise applications.
At scale.
Yes. You need to understand the underlying mechanisms of how foundation models handle application programming interface requests, how they process those context windows at scale, and how they handle network rate limits within the AWS environment.
And that operational understanding brings us to the third skill, which honestly sounds like the most terrifying paradigm shift of all cost management for AI workloads.
It is arguably the most critical operational skill in 2026. I mean, runaway AI costs can and will bankrupt a project if left unchecked.
Let's dig into why this is so different from traditional cloud costs. Because engineers have always had to monitor how many servers they have running. We know how to set billing alarms for an EC2 instance. So what makes generative AI pricing so incredibly volatile?
It comes down to predictability. Traditional compute is largely time-based and predictable. You spin up an EC2 instance, which is essentially renting a virtual server in Amazon's data center, and you know exactly what it costs per hour.
Right, it's a flat rate per hour.
Exactly. Generative AI pricing, particularly in Amazon Bedrock, is completely different. It is generally based on tokens. And a token is essentially a piece of a word or a syllable that is processed in and out of the model.
So essentially, the billing model has shifted from time-based to word-based.
Yeah.
Every time you interact with the API, the cash register rings based on the length of the conversation.
Yes. Every word you send to the model and every word the model generates in response costs a fraction of a cent.
Okay, a fraction of a cent doesn't sound too bad.
On its own, no. But now, imagine a scenario where a developer accidentally builds a recursive loop in their codebug that continuously pings a foundation model in Amazon Bedrock hundreds of times a second
Oh, no.
with massive unoptimized prompts.
Oh, wow. That is a catastrophic scenario.
You aren't just paying for server uptime anymore, you are paying for millions of tokens processed per minute. A minor logic error in your code can result in a massive billing spike overnight.
That's terrifying.
So a modern cloud engineer has to deeply understand how to implement strict API guardrails, set highly sensitive billing alarms, and optimize workloads specifically for these token-based AI models. You have to be fiercely protective of your architecture's financial efficiency.
That tension between time-based traditional infrastructure and word-based AI billing is exactly what we need to navigate. But, looking at these highly practical modern skills like optimizing tokens, managing context windows, troubleshooting AI's hallucinations, they seem somewhat at odds with the traditional path of just studying for multiple choice certification exams.
It highlights the classic tension between foundational theory and real-world practice.
Right, so let's address the reality of the CLFCO2 AML domain versus the massive industry hype. The exam tests foundational knowledge. It asks, do you know what Bedrock is? Do you know what Q is? Can you define a token?
Basic definitions, yes.
But out in the wild, the industry is demanding that you actually know how to stop a runaway token billing spike. So if you are listening to this right now, should you pause your certification studying to just go build things with these AI tools instead? Like, is the exam even relevant when the tools are moving this fast?
This raises an important question about how we validate human competence in an AI-driven era, and the answer really requires a balanced view.
Okay.
You should absolutely not pause your certification studies because the foundational knowledge tested in the CLFCO2 exam provides the essential mental scaffolding you need to understand the cloud. The exam is the map.
And you cannot navigate the terrain without the map.
Precisely. You have to understand what a virtual private cloud is, how identity and access management secures resources, and how S3 buckets store data before you can safely instruct an AI to configure them.
That makes sense?
The AI is a multiplier of your existing knowledge, but mathematically, any number multiplied by zero is still zero. If you lack the foundational knowledge of how AWS operates, the AI will simply help you build broken, insecure architectures much faster than you could on your own.
That is a terrifying thought.
Bah.
Automating the creation of security vulnerabilities because you just didn't know enough to check the AI's work.
Exactly. The multiple choice exam ensures you have the baseline vocabulary and the structural taxonomy of the cloud, but relying solely on the certification is no longer enough in 2026.
Because the game has changed.
The exam tests what things are. The market pays for what you can actively do. You have to pair that foundational exam knowledge with actual hands-on AI fluency.
So what does that look like in practice?
You need to log into the AWS console, open up Amazon Q, and actually try to orchestrate a deployment. You have to experience the friction of a poorly optimized prompt, and you need to feel the panic of a slightly elevated token bill to truly internalize these concepts.
Yeah, that real-world panic teaches you fast.
It really does. The certification is what gets your resume past the HR filter. The hands-on AI fluency is what allows you to actually survive the technical interview and thrive in the role. You need both to cut through the hype.
That is such a clarifying way to synthesize this landscape. You have to build the foundational theory through the exam, but you cannot be afraid to actually log in and orchestrate the environment. So let's take a step back and recap the incredible journey we've explored today.
It's been a lot of ground covered.
It has. We started by looking at this massive explosion of generative AI across the AWS platform throughout 2025 and 2026, a true paradigm shift from manual cloud labor to enterprise-scale cognitive automation.
And we examined how Amazon Bedrock is the engine driving this, removing the impossible financial and computational barriers to entry and offering state-of-the-art foundation models as a simple, accessible service.
Right. And we explored Amazon Q Developer, the AI assistant that sits right beside you in the console, shifting the daily engineering grind from manual clicking and syntax troubleshooting to high-level guided orchestration.
We also confronted the anxiety of replacement, establishing that AI is taking over the repetitive tasks, but the role of the human engineer remains entirely intact. It's just elevated to a higher level of architectural critical thinking and business accountability.
The floor has been permanently raised, which means to survive in this industry, you need the new 2026 skill set. You have to understand the mechanics of prompt engineering and context windows. You have to know how LLM APIs actually function, and you have to be incredibly vigilant about managing the volatile token-based costs of AI workloads.
Absolutely essential skills.
Because as we discussed, if you are listening to this right now, you have the blueprint. You know exactly what the CLF-CO2 exam expects of you, and you know exactly what the real-world terrain demands. By pairing that theoretical certification knowledge with hands-on AI fluency, you are positioning yourself to really orchestrate the future of the cloud.
It is about adapting to a blueprint that is now actively participating in the build. But, we talked a lot today about how critical it is for human engineers to manage the volatile costs of AI workloads and to serve as the financial guardrails against token runaway.
Yeah.
But if AI continues to advance at this blistering pace and continues to replace more complex operational tasks, you have to wonder, how long until these AI assistants are sophisticated enough to analyze, manage, and optimize their own cloud infrastructure costs, entirely cutting humans out of the financial loop?
Wow, when the living blueprint starts automatically auditing and paying its own utility bills?
Yeah.
Yeah, that is a completely different world. Something for all of us to definitely chew on. Thank you so much for joining us on this deep dive into the 2026 AWS landscape. Keep exploring, keep learning, and we will see you next time.